So, what are the secrets behind this global success? Well, the real secrets of an Allison transmission are inherent in the design, embedded in the precision engineering, delivering significant value that shapes the ultimate performance. Value derived from a number of unique features. It all starts with the torque converter. Unlike a manual gearbox or AMT, an Allison fully automatic transmission uses a torque converter module in place of a conventional dry clutch. And what's unique about a torque converter is that it multiplies torque, nearly doubling the engine's torque to launch the vehicle. At ignition, as the engine flywheel rotates and the converter pump rotates with it, pressurized fluid is drawn from the sump into the converter cavity. Centrifugal force causes the fluid to be thrown out from the pump onto the vanes of the converter turbine. As the fluid comes back off the bottom of the turbine blades, it strikes the front face of the stator blades. As the stator is designed not to rotate in that direction, it redirects the fluid back towards the pump at an accelerated rate. And as this cycle is repeated, the fluid gains an extra push, and the rotational force is multiplied, enabling the turbine to transfer up to twice the full engine torque to the drivetrain. This is the vortex flow phase. As the turbine increases speed and approaches the speed of the pump, the converter reaches its maximum efficiency. At this point, the electronic controls activate the lockup clutch that instantly connects the turbine and pump, creating an efficient, direct mechanical connection between engine and drivetrain. Using sophisticated power shifting technology, engine power flows from the turbine to the output shaft through a cascade of planetary gear sets, which can seamlessly apply optimal torque to the driveline through the entire gear range. The planetary gear sets are controlled by a system of multiple wet clutches that work in pairs to implement forward and reverse speeds, with the clutches applied and released hydraulically in response to electronic signals from the transmission control module. This way, Allison transmissions deliver uninterrupted gear changes and ensure maximum engine power and torque flows to the driving wheels. Many Allison transmissions feature an integral hydraulic retarder, a self-contained unit at the output of the transmission consisting of a vaned rotor connected to the output shaft. When the retarder is activated, pressurized fluid is directed into the retarder cavity, where the interaction of the fluid with the vanes causes the retarder rotor speed to reduce, and consequently the output shaft speed to reduce, slowing the vehicle down, or limiting its speed on a downhill grade. Allison automatics incorporate advanced electronic controls that continually monitor and process transmission, engine and vehicle system data. The transmission control module receives information from speed sensors built into the transmission, providing engine, turbine and output speeds. It also exchanges data with the vehicle control network on a data link to interact with other drivetrain components, conveying vehicle management information and responding to driver requests. The driver inputs are communicated to the control module via an electronic shift selector, which also operates as a diagnostics interface. As the Allison TCM processes all this information, it's continuously learning and adapting to road conditions and mission profile, implementing advanced shift strategy for the most efficient and safe operation. The sophisticated architecture is designed to combine the values of the patented torque converter, power shifting, brake retarder, and the advanced controls, enabling an Allison transmission to deliver continuous power technology, achieving uninterrupted and efficient transfer of power from the engine through the transmission and onto the road.